Great.
Hello, and welcome back to our next episode in our InventX demonstration series here at the Aura Innovation Center. This is our, just a few housekeeping rules. Make sure you're all on mute. The chat function and the Q&A function can be used to ask questions, which we'll answer throughout this webinar. We currently do not have the raise hand feature, so that's not something we can do here. So yeah, this is our last episode in our 3D printing series. So today will be hosted by myself and Dr. Ellis Marshall, who will go through metal 3D printing. So I will now pass it over to him.
So brilliant. Thank you very much, Jordan. And thank you everyone for joining me here at the Aura Innovation Center. So yeah, this is the last 3D printing webinar, and we're going to be talking about metal 3D printing. You can see it on screen here. This is actually a 3D printed metal component that we've designed and built here at the Aura Innovation Center. It's actually a gyro mechanism, much like a fidget spinner that we've done. You can actually see in this component the layers that have built up to create this component, and it's made out of stainless steel. Here it is, nice and flat. And then in a minute, we'll see it being manipulated and moved around. So it is a moving functional part which has been 3D printed, which is what I want to get across today. Is they're not just flat components. These are actual moving components that can be manipulated, and they have quite a good level of detail on them, which may be surprising to some viewers of 3D printing, but we can get some good resolution and good properties out of these materials. So this material we printed with today is stainless steel. There is other varieties of materials. I'll go over them later. But this is predominantly one we print in here at the Aura Innovation Center. Various reasons, but because of its mechanical strengths and its availability. So in a minute, I'll be manipulating this component and you'll see the gyros inside moving around with little resistance. This shows the tolerance of this component, and a very good tolerance can be achieved. So yeah, this piece as well was printed in a batch, much like the next one. This one was also printed in a batch. This is a ball bearing socket with a thread on it, all 3D printed, no post-processing finish on this one. So these were batch 3D printed. In a batch, you've got 10 that were 3D printed. I'll go through the process later, and then sintered in a furnace at 1000 degrees. Like I say, I'll go through the process and the green parts in a minute. So yeah, like I say, it's a ball and socket joint. You can see the threads on it beautifully on the inside frame and the outside. And here we are just placing them together and screwing them in. Again, no post-processing. It goes on super easy. There's me fumbling, but. So the process, this is what we use. It's the Markforged Metal X. This is a view of it inside. So what I'm going to do is just pause there for a second. So inside we have two filaments. So we have the metal filament and the ceramic filament. So this may be different to other metal 3D printers that you've seen. A lot of ones on the market do cost a lot because they use powdered metal. So when you use powdered metal, there's a lot of health and safety issues because it's loose metal powder. You don't want to be breathing that in. So you generally have to be in a clean room environment with filters, and you have to be very careful with the metal particulates that you're using. But we here at the ARC use this Markforged technology, which uses a metal filament, which is metal powder bound in a plastic of some kind. So what it does is prints it more or less like a normal 3D printed component through FDM 3D printing. And the ceramic as well can be made through that process of just extruding out of a nozzle. So here is our metal 3D printer in our InventX space. This is in the 3D printing zone. So this is just one part of a multi-step process that we go through. The second step, I'll pause here as well. is to take the green component and wash out any wax. This is done on our wash station, which I haven't viewed here. What it does is get off all wax inside and just leaves a shell of the component. And the reason it leaves a shell is because when you put it in the sinter furnace, like I say, it goes to about 1,000 degrees. The part actually shrinks about 20% or so. I think the maximum is 22%. It depends on the geometries that you've got in your part, what part size it is, the density, as to how it will shrink. And the software we use is very clever and is updated all the time and calculates all that for you. So if you brought a component or a raw file to us, we would do all of the upscaling to get your component out at the end at the right tolerance that you require. And as you've seen as well, it can do threads. It can also do part sizes. So I'm thinking holes in it as well, up to a certain diameter. It can do quite large components, and it can also do very small components. We'll go over the sizing later as well. So yeah, you 3D print your part through that FDM process. You wash it, and then you put it in the sinter furnace here. So this is our sinter furnace hooked up to all kinds of gases. So you place it on the flat surface and slide it into the sinter. This process, the gas furnace takes around 20 hours to do, so a day. That includes warming up and cooling down. And the process is monitored quite closely by the manufacturer, Markforged, as well, to check it meets the certain standards and criteria that they publish and that they stand to. So we can make these types of components again. You can see the layers in this, you can see the thread, and you can see the hole sizes in this component. So this is another component. This is actually for a project at university. This is actually a little exhaust, and it needed to be done out of metal for the application. Exhaust, high temperatures, quite robust, a lot of harsh chemicals going through it. So it had to be stainless steel, and that's what we printed there. These are another set of components. These are actually supplied by our supplier. So these are examples that are on their website as well for Black & Decker and all sorts of other companies. Again, you can see the resolution on the parts. You can see the layer heights. You can see each layer building up and building up. You can see these holes. If these were done with traditional manufacturing methods, there'd be a lot of waste. And internally, you wouldn't be quite sure of what's happening. But here we can be very sure that it's a nice through hole in this component on the right and component on the left as well that can be used in future. And the geometries are within tolerance. So these are all examples of what can be 3D printed here at the Your Innovation Centre, and that have been 3D printed here as well. So this is another project. On the left is the tooled metal component. On the right is the 3D printed metal component. You can tell the difference at the top. There's actually, you can see the internal structure, which is a nice triangular pattern. But if you were to feel the weight of these two components, you can tell the difference. The 3D printed metal part is so much lighter, but as robust mechanically as the first component, as the tool component, and it doesn't take as long, and the cost is a lot less as well. So one consideration we had to make in this component on the right, this 3D printed component, is the direction of the layers. So you can actually see the layers are vertical. So it was built on its side. If it was built with horizontal layers going up, there would be a chance, because this is for a pressure application, that the layers would come apart. So these are services that we offer here to think about your component, to go through your component, help you choose the right dimensions, material, and service that you require for your material. So that's what we can do here. So even though it may sound complicated or you've never thought of these little design iterations, then we can think of that for you and help you out. So this is actually a small company we work with. and do quite a bit of work with them. So the different materials that can be 3D printed here at the or Innovation Centre. We can do stainless steel, like I mentioned before. We can do copper. So copper is quite a nice one for its conductivity. So if you imagine a heat sink 3D printed out of copper, you could change the internal structure beautifully to match whatever shape or design or thermal properties you require. So maybe you need it more dense in certain areas, less dense. Maybe you need holes for a fluid or water to travel through to help cool the system down. These can be all tailored in the design process and not limited to traditional manufacturing techniques. So we can look at the internal structure and figure that out. And along the way, make it lighter and more low carbon. We can also use Inconel, and we can also do tooled steel variations as well. So these are for the hardened properties that you acquire. Maybe examples might be if you're out in a military situation. We will say for these larger companies, they may require a spanner on site and they've just lost all their spanners. You could just 3D print one. Why not? I know that 3D printing, not metal, but other types of 3D printing are readily used on the International Space Station. So they don't have to send up loads of tools, they just send up filament and get 3D printed. It's not metal yet on the space station, but they don't need it. But you could use it for planes, say, engineering tools, engineering techniques, and the manufacturing process. So a cog maybe that's gone in the system, an exhaust pipe like we've seen there, a little widget or a little bit to go in a certain space. We can help with that and choose material to go with that as well. So yeah, we're just going to open up now to a little poll, if that's all right. So the poll will just appear on screen at the minute. So the first question, if you can all see that, have you used metal 3D printing before? I'll invite John as well back and we can ask a few questions as well. The second question is, would you consider metal 3D printing parts for your process? Third question, what materials are you interested in? Are you interested in stainless steel? Are you interested in the copper, the tooled steel, or the Inconel? I have quite a good interest in the copper. I really want to work with a few companies looking at copper filaments and the copper 3D printing. And do you have a project in mind already? If so, yes, we can gladly help you. If no, that's absolutely fine. Maybe you've got one in the future. Please do come back to us and talk to us. We would love to hear from you. So yeah, just the 4 questions we've got today. So have you used metal 3D printing before? Would you consider metal 3D printing parts for your process? What materials are you interested in? And do you have any projects in mind already? So do we have any questions, Jordan?
Yes, we have a few questions from the chat. So our first question is, what resolutions can we print at here?
Brilliant. Okay. So yeah, the layer heights that we can do, 125 microns is the largest, so 0.125 mil, and 50 microns is the lowest, so 0.05 mil.
Cool. Our next question is, can you change the support material and what support materials can be used?
So the only support material available at the minute is the ceramic support material. So when it prints a component, it will print the stainless steel and any overhang. So any parts over 45 degrees, it will place a ceramic butt underneath. You can't change the material. It has to be a ceramic because it's going in a furnace up to 1,000 degrees. So it has to be that ceramic material that is supplied.
And we have one final question. Can you process the parts using traditional methods?
Absolutely, yes. If you require it, you could blast it, sandblast it. You could finish it off with any metal post-processing techniques. You can make it polished. You could do a lot of things to it afterwards in the traditional methods. Absolutely no problem. Yeah, have we got the answers to the poll? Brilliant. So thank you for everyone for voting on these polls. So have you used metal 3D printing before? We've got some yeses and some nos. So hopefully this information today is all brand new to you and you can take in a bit and maybe use it in the future. We'd love that. Again, have you considered metal 3D printing? Maybes, a lot of maybes. No nos, which is absolutely great to see. And so yeah, please do get in touch if you want to metal 3D print some parts. Maybe it's a part you've not thought about, or maybe it's a part that needs replacing every year and you want it in a more robust material. We could look at that with stainless 3D printing or other materials. And again, what materials are you interested in? We've got stainless steel, copper, and tooled steel. That's great to see. Inconel as well is a very interesting material and can be used for specific applications. And then, do you have a project in mind? We've got a few no's, but we've got a few yeses as well. So if you have a project, do get in touch. If you don't, then have a think. I'm sure there's something we can do for you and something we can help you with. So yeah, thank you very much for that poll. Is there any more questions, Jordan?
Yes, actually, yes. I have a project in mind and I was thinking of using stainless steel, but not sure if this is the correct material for the product. Are you able to advise and how do I get in touch?
Most definitely. So please do get in touch with us at aic.aura@hull.ac.uk and we'll be in touch and we can help you with your project. We'll have a meeting, we'll talk about it, see where you want to go, see if stainless steel is the right material for you, metal 3D printing is the right material, and then go from there and work with you and continue our relationship. So yeah, thank you very much for the question. So thank you very much for the metal 3D printing side. I'm just going to do a quick recap on the past webinars we've done. Just as a little recap, and then we'll come back to the metal 3D printing. So thank you very much again for everyone who filled out the poll. So our first webinar was on 3D printing plastics. So this was looking at recycling, it was looking at PLA, ABS, rubberized materials like TPUs, and the applications for these materials. This is quite a long slide that I put here, so it will change in a minute. And then on that first webinar as well, on the overview, we looked at the InventX facilities behind us and what we have access to here at the Aura Innovation Centre. And we have access to a whole host of 3D printers, which we've just about covered through our webinar series. So here's a quick overview. We've got our plastics, resin and metal 3D printing, and then the CAD side of it, which was designed for 3D printing, product visualization, and validating design for manufacture, which is coming up this Thursday. So please do join us for that. So yeah, plastic 3D printing, we looked at the PLA. We looked at how it's used, how it can be recycled as well. So how it can go into a filament extrusion afterwards, how it can be shredded. So here we have an example of shredded PLA, melted and then extruded into a filament and then wound. So we've recently sent 100 kilograms away to go into road use for a local company as well, because we had so much to deal with, we couldn't actually recycle all of it. And we've got loads more in-house that we are now processing into more filament. So I'm just going to pause on this slide. So we've got examples of filaments we could help you work with. So we've got waste materials. We've actually done a bit of work on coffee grounds, putting them into plastic. We've got milk bottle tops, plastic bottle tops, failed components, failed prints, and expensive engineering materials that we could help you process into filaments. So it's whole circular economy side of it as well, which we can help you with. And of course, we did a bit of work at the start of the pandemic on door hooks to stop you touching doors, and also the face visors, both made from recycled products. And these can be used for a variety of other applications as well. So rapid prototyping, 3D printing is great for design iterations and also engineering projects, and all types of projects really. So we went through the 3 techniques of fused deposition modeling with our Ultimaker 3D printers, fused fiber filament with our Markforged X7. This is the carbon fiber, and we went over direct write just briefly. We also went over the history of 3D printing, so where it all started from in 1983 with the stereolithography technology, and then just quickly ran up to where it is today. And there's always new technologies or updates coming to 3D printed technologies and additive manufacturing. And the term additive manufacturing is expanding rapidly each year. So here we have an example of our fused fiber filament. Here's an example of our tool component I showed you earlier, a resin component, a carbon fiber component, and then the metal component 3D printed. So one component and 3 different materials. So if you do have that product, we can help you find the right material to 3D print with. So again, this is inside our InventX 3D printer. Looking at the filaments. And the gyro. And you can see it rotate as well in this one. So the tolerance is very small on it between the components, and we've actually fixed it so that they can rotate around quite nicely and still stay in shape. So this was 3D printed all in one print as well. There was no putting the components in afterwards, all did in one print, and no loosening between, no ceramic to come off between the layers as well. And again, we have our other component where we just twist it in, screw thread. This is me fumbling around trying to get a screw thread in. And then we can do other components. So we've got examples here of organs that we've 3D printed. And then I just want to take time as well to say, please do join us for our final webinar, actually, isn't it? On computer-aided design, validating for design for manufacture. So that comes up on Thursday at 11:30. Please do join us for that. That's our final one. We'll have a big send-off. We've really enjoyed doing this webinar series. So we do look forward to that. And then I'm just going to show you the next ones coming up or what we've done already. So again, we've done 3D printed with plastics, we've done resins, and we've done metal now. Computer-aided design, we've done design for 3D printing, product visualization, and Thursday comes design for manufacture. All our past webinars are now available on YouTube. Please do follow us on Twitter or follow us on LinkedIn or go to our website and you'll find the links, or Google us and YouTube us. We've got an upcoming series in June on advanced materials testing, which we'll announce more detail on very soon. In July, we've got printed circuit boards or electronic control systems. And then we're working on the final one in September, or final one of this list. I'm sure there will be plenty more on augmented reality and virtual reality. So if you are interested in that AR, VR side as well, we did a bit in the product visualization where Jordan went through putting on a headset and showing a design and how it can be manipulated in virtual reality. So if you are interested, please do check out our product visualization webinar run by Jordan. So yeah, Jordan, have we got any more questions?
Yes, we do. We have another question here. So what are the benefits to printing with metal as opposed to other materials?
Okay, so the benefit of metal, so it can go to high temperatures. It can work with quite corrosive materials. So if you're working with acids, bases, anything on a high or low pH would work well with metals. If you're using plastics, they may dissolve in certain solvents if you're using quite harsh solvents or chlorinated solvents. So there is a benefit depending on chemicals that you are using, or mechanical property wise, if you need a high tensile strength, then obviously you go from the metal sides. If you don't require it so tough, you could go the carbon fiber. And if you just need a component to fit, you could maybe go plastics, or resins are really good. And resins are surprisingly mechanically strong as well, and do compare to metal 3D printed parts in some cases. So yeah, if you've got a material in mind, please do talk to us, and we may change your mind and upgrade it up to metal or another component, or we may inlay carbon fiber or other components into it. So if you've got a property that you desire, do get in touch and we can make it happen. So yeah, thank you very much for that question.
So we have a follow-up question to that question. Will this be more costly?
More costly than traditional manufacturing? No, it will be cheaper overall, especially if you're talking design iterations. That's what 3D printing is made for. It's made to go over these multiple design iterations rapidly and get you a product. So in the timeline of events, it will save you money for sure. You don't want to get to your final tooling method if you're making a component and a design to be wrong and you spent 20 grand. You'd rather spend a couple of grand and get it right, and then move on to other methods of manufacturing. Yeah, thank you very much for that question. So a few little bits that I forgot to talk about. So we were talking about components and putting holes in components. So we've got a minimum hole diameter that you can 3D print in metal, which is 1.5 mil. If you want to work with us at the minute, we are able to 3D print in metal up to certain sizes. So I've got the list here, so I'm just looking down. So it's 235 mil in the X, in the Y, about 60 mil, and then in the Z, 80 mil. So quite large, bulky components, but what this metal 3D printing method is good for is batch components. So the minimum size we can do is 2.8 mil in the X and the Y, and 1.7 in the Z. So very small components, and it will be very good for printing a batch of, say, 10 or 15 of those components in one go. So it is a batch process, really, and that's what it's good for. It can be used for the one-off large prototypes as well. Yeah, have we got any more questions, Jordan?
No more has come up.
No problem. So yeah, we'll move on to the thank yous. So yeah, thank you very much for joining us. I'll just give a brief overrun of what we've just talked about. So if you need any metal 3D printing, do get in touch. Our materials that we can 3D print with are stainless steel. We've got the copper. We've got the Inconel and the tooled steel. And there is other materials that are being developed that are in beta testing with the manufacturer, which is Markforged. So that will be updated quite regularly, I reckon. And there'll be new materials coming out. And the benefit of working with us at the Aura Innovation Centre, if you want the post-processing doing, we actually have fabrication facilities down on campus. We have a workshop down there that would be able to process the parts that work with metal all the time, and would be able to do a good finish on these components. So you're not alone. You don't have to do all the work. We can help. We can assist. We are the University of Hull. We do have access to other academics as well. So if you have a unique project or a bit of a research project, we could help you out with that. That's no problem at all. Anything so wide and anything so narrow, we can definitely have a look at and see what we can do. But yeah, how to get in touch? It's just get in touch with us at aic.aura@hull.ac.uk. You can follow us on Twitter and find us on LinkedIn. So finally, so this is my last webinar, so it would be great to say thank you very much for joining us. We hope to see you all again soon, and thank you very much for those joining on YouTube later on, and thank you to our live audience. So Jordan?
Yeah, thank you for all coming. We have one more webinar in the computer-aided design series, which will be on Thursday, so you're all welcome to come to that. And thank you for coming to this webinar.
Brilliant. Thank you.
Thanks. Bye.